Hello everyone and welcome to the first episode in this new tutorial series about rendering water using OpenGL. This series will take you through the process of creating some rippling, reflective, refractive, sparkling water using the modern OpenGL API. So that's the programmable pipeline and not the old fixed function pipeline. You should be able to follow along with this series regardless of what language you're programming in, because almost all of the code in this tutorial is either OpenGL calls or shader code, which would be the same in any language. I myself am going to be demonstrating the process using Java and the lightweight Java game library, but anyone with a basic knowledge of OpenGL and general programming should be more than able to follow along. This series is aimed at people who already have a good understanding of the basic concepts of the modern OpenGL pipeline and who understand the basics of GLSL, the OpenGL shading language, which we're going to be using a lot of in this series. I'm going to be demonstrating the water using the basic 3D engine that we've been creating in my beginners OpenGL series, which you can check out here if you'd like to learn the basics of 3D rendering first. Of course, you don't need to have followed my other tutorial series to do this one, but you will need a working 3D engine that uses the modern programmable pipeline OpenGL. I'm going to assume that in your engine somewhere you have a way of rendering all of the objects in your scene, and it might make things easier for you if you put all of the rendering stuff in one method. So this method would do everything from clearing the color and depth buffers to starting and stopping shader programs and calling all of the necessary draw commands. So basically everything you would need to render the scene from scratch. If you don't want to put all of this into one method, then that's fine, but whenever I call this method, just remember that it means that you have to carry out the full rendering process, because for rendering water we will actually need to do this multiple times every frame. If you're using the engine from my other tutorials, then you can create this method here in the MasterRenderer, and then you can call it from the main game loop when you want to render the scene, like I've done here. Notice though that it only renders the 3D objects in the scene, and all of the GUI rendering is still done separately. So I'm just going to give a quick overview now of how we're going to be achieving the water effect over the next few weeks. The water is actually just going to be a completely flat quad, and we're going to be using some clever shader techniques to make it look like it's a rippling reflective surface. The first thing that we'll need to do is to render the scene to some textures. This is basically like taking a picture of the scene and storing the result in a texture that we can then use just like any other texture. Before rendering the water each frame, we'll take two pictures of the scene. One of everything under the water, which we'll save in the refraction texture, and one from a slightly different camera angle of everything above the water, which will be the reflection texture. When we render the water quad, we'll use these two textures to texture the quad. But instead of just texturing the water normally, we'll first distort these two textures using something called a du-dv map. The distortion will change over time, giving the impression that the textures are rippling. We'll then blend these two distorted textures together on the water's surface using the Fresnel effect. This just determines how much of each texture should be seen based on the viewing angle, so that when you look straight down into the water, it appears to be fairly transparent, but when you look across the water's surface at a low angle, it looks more reflective. We'll then add some lighting calculations with the help of a normal map to make the water look like it isn't flat, and we'll add some specular lighting to make the water glisten in the sunlight. Finally, we'll soften the edges of the water and possibly make the deeper areas look a little bit more murky using a depth texture which we'll create when we render the refraction texture. So that's what we're going to be doing over the next few weeks. Don't worry if you didn't understand all of it right now, I'll be explaining each step in detail in the tutorials to come. To get started this week though, I've written some very simple code for you which renders a flat quad with a new shader program, which we'll later be using to create the water effect. I'm not going to take you through this code because if you're doing this tutorial series then you really should already know how to render a simple quad using VAOs, so you can just download the code from the description of this video and copy it into your project. So just create a water package in your project and then put those classes and the shader files into there. If you have a quick look through that code, you shouldn't see anything new here. I'm just loading up a quad into a VAO, and then I've made a renderer and a shader class to render the quad in the simplest way possible. The shader program itself is basically completely empty right now, with the fragment shader just setting all of the pixels in the quad to blue. So copy that into your code, or if you're not using lightweight Java game library, then set up an equivalent system, and then test it out. So when you load up the game, you'll need to create a new water shader somewhere and a new water renderer, and then create a list of water tiles and add to that list any water tiles that you want to render, making sure to choose some suitable X and Z positions for the tiles. Then in your game loop, after rendering the 3D scene but before rendering any of the GUIs, you can render your water tiles like this. And don't forget to clean up the water shader when you close the game. So then you can go ahead and run that, and somewhere you should have a big blue quad. If you can't see the quad, then just make sure that you put the water tile in a position where it's actually visible, so not below the terrain or miles up in the air. So just make sure that you've chosen a suitable height value here. So that is it for this simple introduction video. I'm going to be trying to upload these tutorials every 2 weeks on Saturdays, but please don't hate me if I occasionally miss a week because I am very busy planning for my Kickstarter campaign right now. Next week we're going to be using frame buffer objects to render to a texture, and you can have a look at the rough schedule for this series in the description of this video. But yeah, thank you guys very much for watching this video. Do subscribe if you haven't already. Have a brilliant week, and I will see you all next time.